Hello everyone, welcome to my channel. Today I will present to you a tutorial divided into two important parts. The first concerns fully qualified domain names or FQDNs, and the second will show how to modify the configuration or core DNS in Kubernetes to forward traffic to an external DNS server's IP address. These skills are extremely valuable in managing modern IT infrastructure. Let's get started. Here I have a command line, and this is the host where my AWX is running, so I'm going to show you what exactly we are talking about. So first of all, kubectl get pods and then in a namespace AWX. Here we have AWX that is running on this Kubernetes cluster, right? And this AWX has something like web panel GUI where you can manage many multiple jobs. For example, you can update systems, upgrade them, you can delete files, you can do a lot of things. And here these jobs can be executed thanks to the inventory. What is inventory? Inventory is a group of hosts, and you can define them using IP address or using the fully qualified domain. And what is fully qualified domain? It's a complete domain name that uniquely identifies a host on the internet. It consists of the host name and the domain, providing a unique address. Why is this important? In the world of computer networks, clarity and precision are key. FQDNs allow for clear communication, eliminating any misunderstandings related to addressing. Using FQDN is also best practice in configuring services and network devices because they provide a constant point of reference regardless of changes in IP addresses. Now that you know what an FQDN is and why it is so important, let's move and let's check what we can do using AWX. So here you can see we have hosts. And these hosts you can add here and assign to an inventory, or you can create an inventory. I can show you how to do that. So you can choose, click on this blue button, choose an inventory, provide a name, provide a description, organization, instance group if you want to, but you can also add labels if you want to, but you don't have to. All you need to do, in fact, are those two fields, name and an organization. So we see start here, and then you need to save it. After you will save it, you will see something like this. You have a list of inventories, so you can choose one, and for example I will choose the ranger, let's say. And here you can see something like a host tab, and in this host tab you can add a host. So you can add it also here. So you need to provide a fully qualified domain here, and the description you can provide anything what you actually want. I will cancel it, and instead I will edit the host that I already added to this ranger inventory. So here you have ranger.local. This is my FQDN, and description is exactly the same, but I can change it if I want to. Doesn't matter. So this is the way. You can create inventory, then go to host and create host and add to inventory, or create inventory, then not edit it but just click on the name of it, go to the host tab and add a host here. But this is not everything you need to do. I mean, this is the only one part of the job, let's say. First of all, because this is strictly connected with AWX, right? And where additionally we need to provide FQDN and how to make it work. But before I will switch to the GitLab that is connected to AWX. I will try to explain everything. I already created a tutorial about configuration of GitLab and AWX and how to connect them together. So you need to watch it to understand how I did it. However, I will try to quickly show you what is going on here. I mean, here you have project. So I'm using the project that is already created in previous tutorial, and I will be using only this one because it is able to connect to my GitLab. How? And if I will edit it, you can see the field. That is crucial actually here. There is a URL and the source control branch. So if I will go here, this is my project, and I will click on it, you will see the repository, and this is my repository. And thanks this, and if you will click on the code, you can clone the URL using a Git or HTTPS. And what I did, I provided this URL here, and here you can see there is a main branch. I do not use any other. And here I provided main, and there is a GitLab private key, of course, name, description, organization, and source control Git. And that's it. And the crucial part is here, update revision on launch. And I will explain in a moment how it is working. So you need to save it. And this is the project. Then you need to create a job template. So you go to template. And here I have a template that is already created, but you can also click on add and add a job template, and I will do that just to show you. And this is something like this. So you need to fill these fields, and now I will cancel it and I will edit the one that I already created, so you will see how I provided all the information into these fields. So name, description, job type, run or check. Then inventory. Why? Because AWX needs to know where to connect. I mean, on which remote host to execute it. Actually, this is a crucial part. Without this, it will not be able to make it work. Then the project. So you pick up the project that allows you to connect to GitLab, right? So this is the project that I currently chosen. And it is able to connect to my GitLab and pick up the repository. Then control plane execution environment, and here you can choose from the drop-down list the playbook that you want to run on a remote host. So in my case, I'm going to update my Ranger using my FQDN, and this is everything what you need to do in AWX. Of course, there are other parts like credentials, so you need to configure the connection between AWX and GitLab. So watch my previous tutorial, because without this you will not be able to perform this task. Now we are going to GitLab, and in GitLab you have something like group list of playbooks. In my case, that I'm going to run them. So in my case, I will use updates-ranger.yml. But before I will do this, I will show you the playbook that I created previously. And here you have something like host all and then a list of tasks. And now go back to update-ranger.yml file, and you can see instead of all, I have something like double curly brackets, and inside I have a variable FQDN. And yes, it is also using FQDN in GitLab. So you can define it here, and then you can create vars. I mean, vars files, it's something that is a must-have. You cannot change this line and call it differently, but then the dash and name of the directory and slash and name of the file. So this vars and FQDN, this is something that you can call as you really want. I just gave these names to, clarify everything. So thanks this, in vars directory, I keep all the variables. Great. And now go back, and here you can see we have a list of our playbooks, but also there is a vars directory, and inside of it there is a fqdn.yml file, but the file can be something like ranger.local.yml. Well, why not? And here, when I will click it, you can see that it contains fqdn ranger.local. Only one line, and that's it. And you can even edit the single file, and make sure that it contains only one line. So you can even get rid of this one line, commit changed. And now it is a time to just clarify one thing, how we work in companies. Well, we are doing something like this. We are creating another branch. We are copying and we are using a master or main branch as a source, so it will pick up all the files. Then in our branch we modify, let's say that we change some part to make some kind of an improvement. Then we create a commit, so we push it to our branch. Then we create a merge request, and after that someone reviews it, and it is assessing the merge request. So the change from your branch goes to your master or main branch. And this is the way we work. And why I talked about this, I will give you a moment, an overview why it is so important. Okay, so we have a vars. We have a file inside vars where our FQDN is defined. We have Ansible playbook where we define FQDN and where it can find the variable. Great. Let's go back to AWX. Just now I will try to explain everything step by step. So this is my template, right? And of course you fill all those fields, and after that you click save. Okay, fine. Now you can go back to templates, and there are two options to run a job template. So the first one is this rocket icon, so you can click on it, or you can click on the name of a job template and then click the launch button. And now the magic happens. What is going on here? If you will click on jobs, you will see that in the first place there is a job updates via GitLab Ansible project running. And this is something that is running in background. You can see the progress here. Why? Just because if you will go to project, and this is something that I already explained, if I will click on edit icon, and I will show you this update, revision on launch. I was talking about it, how it behaves. I mean, when you run a job template that is using a project that has this option selected, then after you will click launch job template, what is going on? It is running first of all a project. Why? To pick up new versions of the whole files after the merge request. And thanks this, it will be able to pick up new version and then perform a job. So you will not have old entries, old data from the old version of an old playbook, but instead you will use a new one that someone, or you or maybe someone from your team modified it, so you can use a new version of Ansible playbook. And now you can click on the update ranger and waiting for job output. And if you're curious why it takes so long, because I talked a lot and it's still waiting for job output, I will show you this. And in the background it is creating something like an automation job and random string pod. So it is creating in pod with container, and it is executing a job inside a pod, inside a container. So this is the way it works. So we can observe using watch command in the beginning, and after that, when it will show you the status that it is running, then you will be able to observe all of this in this browser, so we can switch here and we can eventually find out what is going on here, and it should run in a moment. So it is a crucial step to wait a little bit. But to be honest, you're not obliged to observe the status in this window, just because this is an automation tool. So by default it should send the result of the job to some, I don't know, log server, to Grafana or something else, you know, Elasticsearch, hard to say, maybe Zabbix, something like that, and it will inform you that the job finished successfully or it failed. So then you'll be able to log in and check why it failed. It should provide you an information why it fails and why it happens. Okay, seems it took a lot of time to create this. I don't know why. Usually it takes much less time. I mean, it is running much faster, but for some reason today, now it is running. So yeah, you can see the progress, gathering facts, and then check for available updates. This is the next task, and if there will be an update, it will perform a next task, or it will skip it if it will everything will be up to date. Okay, changed. So changed means it performed a command sudo apt update, then update aptcc if updates. Okay, so there was an update. Check if restart is needed. Okay, and you can see, okay, 4 changed 1. I mean, change, it performed a command, and there is no skip. So there was an update, it did the update, and that's it. So the whole job is correctly running. There is no problem with it. Fine. And now, what if it will fail and you would like to know what is going on? The best option is to check the connectivity to the remote host. So I will show you how to do that because it is quite easy. I will try to open, this one, and here I will click Ctrl+C, and now I'm going to show you how to perform a check, so you will be able to check the connectivity to the host that in fact failed. So first of all, we need to run some kind of pod, and then to perform a command inside this pod, inside this container. And because AWX doesn't allow you to run sudo command, and it doesn't have tools like, for example, NSLookup, I will use an image for the container, and it will be a busy box. So let's do that. kubectl, then run, and then it, and --rm --restart equals never, and after that busy box, it is a name for our pod, and --image and equals busy box, now colon, and provide a version, for example 1.28 --, and now we will call up shell because it doesn't contain the bash. Yeah, so it can contain ash, bash, sh, I mean shell, and it depends on the container, on the actually what is running, what operating system is running in this container. And BusyBox contains tools like NSLookup, ping, so I can use them to perform a really simple check. But first of all, we need to run it and wait for the shell. Now we are inside this container, so NSLookup, and if, for example, my job that is connecting to rancher.local will fail, I can check, do I have a connectivity to remote host, and in this case you can see it returned address 123 at the end, right? 10.10.0.123 range. So it means there is a connectivity, and also you can ping this IP address, so ping 10.10.0.123, and you should see the result. Why I didn't provide something like -n and 4, for example, to attempt it only 4 times, because this ping version is just something that is an old version, and you can see a health like that, and it supports only these flags. Not much, but the simple ping is working, so you can check. Also, you can check something like, I don't know, a remote host. So you can check, can we ping something else? Let's say I will try to ping google.com maybe, and you can see it's working correctly. It is recognizing the IP address. And nba.com, why not? Here we go, it is working. So it is connecting outside and it is providing. So our DNS is working correctly. It is a core DNS inside the Kubernetes cluster, and it is working without any issue. And now it is a time to actually show you the second part of our tutorial. So this is a tutorial about core DNS, and you would like to know what core DNS is, and I'm going to explain you everything, so I will tell you more about it. Core DNS is a powerful, flexible and extendable DNS server, widely used in Kubernetes. However, sometimes we need to customize its operation to our specific needs. For example, by redirecting DNS queries to external servers. How we do this? So let's start by opening the core DNS configuration file, and I will show you how to save this core DNS config map to a file. This file will be then edited, and I will show you how to add a forward section, and this section is responsible for redirecting traffic to an external DNS server. So it is very important to make these changes carefully, because errors in DNS configuration can cause connectivity issues throughout the cluster. After making and saving changes, we will restart core DNS so that the new configuration takes effect. Remember to check that everything works correctly after this change. So, what you need to do to make it work? First of all, I will edit this pod, so it will be deleted in a moment. Okay, fine. And now, if you want to save this file, this configuration file, this core DNS config map, you need to perform this command. So kubectl, then in a namespace kube-system, and get config map core DNS, because we are picking up this file, configuration file, output yum, and it will go to core dns.yml like that. Then edit this core DNS and go to forward rule forward.etcresolve.conf in this core file, right? So this is the core file section, and you are modifying this forward rule in this core file section. So hit insert, and at the end make a space, open a curly bracket, then you need to modify it properly. So now we will add custom forwarding rule under the existing forward.etcresolve.conf directive, right? So for example, if you want all DNS queries except those for internal Kubernetes services clustered with local to go to the external DNS server, let's say it will be my DNS, and I will show you what I'm exactly talking about. So I will go to browser, and this is my add-get home. It has an IP address 10.10.0.108, and then I will go to filters and DNS rewrite, and here I have ranger.local. So instead of using the internal core DNS Kubernetes DNS, right, I would like to use my external DNS. Okay, so let's go back to the command line, and now we are going to modify this core file like so. Fine. So after you open the curly bracket, you need to I did a mistake here, and yeah, this way you need to add something like except, so except cluster.local, and then in -addr dot arpa, right, and ip6 dot arpa. Okay, close the curly bracket and add one more line, so forward dot something like this, and now provide the IP address of the external DNS server. So in my case it's a 10.10.0.108. That's it. Then exit saving the file. Then we can cut this file, core DNS, and it should contain our entry, and you can see it contains this and this. So okay, sorry, I will edit it one more time. And now what we can do something like this. We can copy this core DNS to core DNS, but I will change the name modified, and then I will edit the original one, and I will get rid of this because I need an original file without modification. So I will save it just for future to know what I'm going to do. I mean, if I would like to go back to this previous state, then I have an original file that I can use and exactly know what I need to delete. But I will show you how to modify it and how to make it work, because this is a crucial part that you need to understand how to behave each single time. And I will explain in a moment what I'm exactly talking about. Okay, so yeah, we have an original version, we have a modified version. So now we want to change this config map. So we need to apply this new modified core DNS. So kubectl, then apply, and then -f and the core DNS, but the one that is modified. And here we go, config map core DNS configured. And the next explanation actually how it is behaving. So let's cut this core DNS modified version, and let's focus one more time on these lines. So the forward.etc resolve, and then curly bracket, and except cluster .local in .arpa and ip6.arpa, this one. This line is specifying that general queries should use the systems resolve conf, which typically points to the default Kubernetes DNS service, except for the specified internal domains. And this line, forward 10.10.0.108 line, then specifies that all other queries not caught by the first rule should be forwarded to your external DNS server. And after updating the config map, so after performing a command kubectl apply, and I will clear the screen, you need to restart the core DNS pods to apply the changes. So you can do this by deleting the existing core DNS pods, and Kubernetes will automatically recreate them with the updated configuration because it is configured the way to make it work. Automatically will recreate the core DNS pod. So kubectl, then dash and provide a namespace. Always work with namespace kube system. Sorry, my fault. This way, and then delete pods, and after delete and like that, delete pods dash l k8s dash up equals kube dash DNS. Fine, and it should get rid of this pod. And when I will rerun this command once again, but I will get rid of this and will use get command, you can see it recreated the core DNS pod, but with a different string at the end. Okay, fine. So this is running. So after the core DNS pods are up and running again, test the DNS resolution to ensure that internal Kubernetes services are resolved correctly, external domains are resolved via your home lab DNS or server or external DNS server in your company. And you can do this, of course, using the already known command that I presented previously. So we will run busybox once again, and we will run nslookup to perform a check, and then also a ping command to be sure that it is working as expected. So by following these steps, you should be able to set up your K3 or K8 clusters DNS resolution to meet your specific needs while maintaining proper function for both internal and external name resolution. Okay, nslookup, and let's say rancher.local, and here we go, it is working. Also we can check nba.com, why not, or BBC CEO UK, right? And this one, it's working a lot. Okay, and what about I don't know, just google.com, it's working. And let's say I would like to also test my internal domain that I'm using only in my home lab, so it will be something like this, admin.homes, it's working. And also I will show you one simple trick, AWX, and here we go, let's say Argo CD, and now also something like GitLab, for example. And you can see all these three are showing all the same time IP address. And you're wondering why I'm showing you this and why it shows that there is a same IP address. This is a really good question. So let's go back to browser. And here I will show you I'm using something like Nginx Proxy Manager. So it behaves like a proxy. This is a proxy actually, and Nginx is actually working the way that like just a simple web server, but a little bit different. But the basic web server can handle a lot of domains. So you have only one IP address of the server, of the web server, and you have something like virtual host. So every time when you're using some kind of external DNS checker, some kind of service, like you can check one domain, two domains, three domains, and the second, third, fifth domain shows, for example, that these domains, they are located on the, they pointing actually, maybe not located, they pointing the same IP address of the server that is hosting this file. So on the standard web server, it's using something like virtual host, and so it tells that okay, for this domain, virtual host provides this path on this server. For this domain, it provides a different path. So all the files that are inside a proper path are served for a specific domain, and the proxy working the way a little bit different, but what it is doing, it is changing this let's say a subdomain, right? Because I'm using wildcard, so it's changing it redirects the traffic from the subdomain. For example, adgat portainer, it goes to this IP address with this port. For example, for Argo CD, it goes to this IP, right? For the AWX, it goes to this IP, and for a GitLab, it goes to this IP. So it is working with redirection. But if you are using something like NSLookup tool and you are asking for a subdomain, domain of FQDN actually, it returns the address of the server that is hosting this kind of resource. And in my case, the Nginx proxy manager is serving this kind of service, is serving this FQDNs. And my adgat home is serving only rancher.local. So if I will add another domain and totally separated from this, let's say it can be something like AWX.local, and I will then ask with NSLookup for AWX.local, for example, then it will show me the IP address that will be defined here. So what we can do, we can try to do something like this. I can copy these testings. Let's go back to command line and we will see is it working. I hope it will. So NSLookup, but instead we can try something like this. And what is going on here? 10.10.0.126. So let's go back to browser and we can see here exactly. This is the IP address that is located in a DNS entry, right? So DNS returns the IP address that is assigned to a proper domain or subdomain, and thanks to this you can achieve your goal. I hope you enjoyed this video, so thank you very much. Have a nice day or night. Take care. Bye bye.